Okay, so in the last video, we spoke about exponentials at the most basic level, right? So y equals b to the x. So this is what we did in the last video. And we spoke about how when b is greater than 1, you have exponential growth. So when b is 2, 3, 4, 1.5, 1.001, it is growth. When it is less than 1, but still a positive number, it is going to be decay. Okay, so let's talk about what that means practically. So this is what's going to help you do your worksheets. So when I have y equals ab to the x, this is like your formula, essentially. Kind of like our standard form. So when we did quadratics, we had things like y equals ax squared plus bx plus c, stuff like that. This is going to be your model that you're working with. Y equals ab to the x. So we spoke about it in the last video where a is your coefficient, right? We labeled it your coefficient, but right here, that coefficient is going to stand for something when we are doing word problems. So just bear with me. B is your base or your multiplier. X is your independent variable. And y is your dependent variable. Okay. So when we are dealing with word problems or problems that are not just a formula, okay? So when we're dealing with things that have context, right? So most of your problems on this has context. And we're going to talk about what each of these means. So first I want to show you on Desmos what it means. So I'm actually going to delete this. And now we have y equals ab to the x, right? This is times a times b to the x. If, let's put a is equal to 1, okay? If there is no a value, it is the same thing as saying a is equal to 1. The same way how when we have something like y equals x squared, the a value here is 1x squared. Or in the same way, when we have x by itself, it is the same thing as saying 1x to the first. It is implied, if it is not there, that it is a 1. So if I have b equals, I gotta show the function, 2 to the x. So it's 1 times 2 to the x. Excuse me, you are going to see the function as exponential growth, right? And it has this starting point of 0, 1. Oh my gosh, no way. So weird. It starts at 1 and a is 1. Now what happens when a becomes 2? What is my starting point now? It is 2. When a becomes 3, it's now 3, right? So no matter what, my function can move all these different ways, but has my starting point changed? No. A is going to be your starting point or your y-intercept if it is in y equals ab to the x. Okay, so that means that when x equals 0, y equals whatever a is. So let's talk about why that happens. So if I have y equals ab to the x, here's something we may have spoken about, we may not have spoken about, or you may have heard before. Anything to the 0 power is equal to 1 except 0. So this is a property, okay? So 2 to the 0 power is equal to 1. 6 to the 0 power is equal to 1. 8 to the 0 power is equal to 1, okay? Negative 6 to the 0 power is equal to 1. 1/2 to, you get the point? The only thing, 0 to the 0 power is not equal to 1. It is undefined. So if I have y equals ab to the x, and I want to know what is my y-intercept. So y-intercept means x equals 0. That has not changed. So I have y equals, I'm going to rewrite this in red. So y equals what? Y-intercept x equals 0, right? So I have AB to the 0 power. So again, PEMDAS tells me to do this first, right? So I have b to the 0 power is equal to 1. B to the 0 power is equal to 1. As long as b is not 0, but we already know from the last video, b cannot be equal to 0. So I have y equals a times 1, so y equals a. So I know that on my graph, I'm going to have 0, which I plugged in 0, and 1. A. 0, A is on my graph. So I know when x is 0, y is going to be a, no matter what. So a is my initial value. Now, a lot of times when we do all these problems, x is my time, okay? So I'm going to write here, independent variable. Now, I'm going to make a little bit more room. Actually, do it here like this. And I'll put here, usually, time. So what that means is that at 0 time, or at my starting time, I have my initial value. A lot of times when we do this, it's money, okay? So B is going to be my multiplier, my base. But the way that we call this is my growth or decay factor. Because it's telling me at what rate is it growing or decaying. And then y is my dependent variable, or my final amount, my final value. So I have my initial value and my final value. And R, and we're going to talk about R in a second. So my last video, we spoke about how when B is equal to 2 versus B is equal to 3, this grows at a faster rate, right? And we also have, if we have B equals 1.5 versus B equals 1.1, this is going to grow at a faster rate because B is larger. So the way that we break this down is we say, okay, so if it is growth, that means that B needs to be greater than 0. So growth is B is greater than 1. I'm sorry. B is greater than 1. So that means it's 1 plus a number, and we're going to call that R. And R is our growth rate. Okay? This is the thing that a lot of people get mixed up. So if I have y equals b, y equals, let's say, 1.2 squared. What is b? B is 1.2, which I can rewrite this as 1 plus 0.2. So that means that R, so B is equal to 1.2, and that means R is equal to, see how we have 1 plus R? So it's going to be 0.2. R is equal to 0.2. So my growth rate, and we spoke about how to convert decimals to percentages and vice versa. My growth rate is going to be, if I move this 2 units, 20%. So whatever this is growing at a rate of 20%. So let's look at what it would look like for it to be decaying at a rate of 20%. Meaning, if I want it to be decaying at a rate of, and and I'll keep my consistency in green, of 20%, then that means that it has to be y equals 1 minus 0.2, right? Because 20% is equal to 0.2. We don't put percentages in formulas. We put them as decimals to the x power. And so I have 1 minus 0.2, and 1 minus 0.2 is 0.8 to the x. This would have, so that means r is equal to 0.2, and that is how we find that. It is really important here that we notice that for growth, we had 1.2, which is greater than 1. For decay, we had 0.8, which is less than 1. If you don't find that it's following that pattern, then something is wrong. So if I were you, I would pause this video. I mean, this is actually on your sheet, but don't look at it. Pause this video and try and figure out what the initial amount is for each of these and what is the growth or decay rate. Okay? If I were you, I would set this up and I would put what is A, what is B, and what is R. Okay, I'm just going to keep going for the sake that this video is not 75 minutes. A is equal to 300, right? So we know that A is equal to 300. So my initial amount, if this was like a bank account problem, I would have $300 starting. Okay, that is my initial amount. Okay, I'm going to write that here. Initial amount. And then I have, what is B? B is this entire thing. So it's going to be 1.06. That is the, if we look up here, it is the growth or decay. It is the growth factor. I know it's going to be the growth factor because it is greater than 1. And then I know my growth rate is going to be, so this is the same thing as saying 1 plus 0.6, and 0.6 is the same thing as saying 60%. So I'm going to write here 0.6 is my growth rate, and I'm also going to write 60%. Okay, R is equal to 0.6, but technically my growth rate has a 60% growth rate. And then same concept here. It also has 300. My B value is 0.75. So therefore, my R is, so 0.75 is 1 minus how much? 0.25. So therefore, it's 25%. So this is 0.25, which is equal to 25%. Okay, so these are the 2 word problems that are on your sheet. I'm going to go through them. Even though you have the answers, I'm going to go through them with you because it's going to help you complete the rest of the problems in your assignment. So Kristen invested $2,000 into a CD. That's like a online banking thing that collects interest. Okay, so you can give a CD to a baby and they can't touch it. And when they go to college or something, it'll have a lot of money in it because it'll just collect interest. So invested $2,000 into a CD. Automatically, I know that this is my A value because that is the initial value. And it has a 5% annual interest rate. So it's growing at 5%. So I know automatically that 5% is, so this is my R. R equals 5%. What's 5% as a decimal? 0.05. Write an equation that represents the amount of money in the CD over time. So I know it's going to be y equals A times 1 plus r to the x. 1 plus r because it's growth. So it's going to be y equals 2,000 1 plus my r, which is 0.05 to the x. So it's y equals 2000, 1.05 to the x. There's your final answer. How much money will she have after 15 years? So after 15 years, remember we said time is usually my x value. Okay, so all I'm going to do is plug in 15 into my equation. So I have y equals 2000 times 1.05 to the x, and I plug in, so this 15 years is going into here. So I plug in 15, so I get y equals 2000, 1.05 to the 15th power. Again, PEMDAS tells me I do this first. So I get a calculator, and I do 1.05 to the power of 15, and I get 2.079. So this becomes equal to 2000 times 2.079. And then I just multiply. Oh, I shouldn't have closed this out. So 2.079 times 2000 is 4158. 4158. So my final answer is she will have, and you have to write it as money. So even if it's a decimal, you have to round to the nearest cent. Okay, so that's growth. Let's talk about decay. So Quinn's new motorcycle is valued at $15,000. Guess what that is? My initial amount. Oh my God. So this is A. With an annual depreciation means decay of 25%. So that means that this rate of 25% is going to be R is equal to, so R is equal to 0.25. Find the value of the motorcycle after 5 years. So first you have to get your equation. Okay, so I have y equals ax, a1 minus r, because it's decay, squared, not squared, to the x. So I have y equals 15,000, because that's my a value, times 1 minus 0.25 to the x power. And so this becomes y equals 15,000, 0.75 to the x. This is my equation, but that's not my final answer because it asks me, what is the value? Find the value of the motorcycle after 5 years. So that means x is equal to 5. So x equals 5. So we plug that in here and we get y equals 15,000 times 0.75 to the 5th power. Let me put that in blue. Again, I'm going to emphasize it. You do this first. So I get 0.75 to the 5th power. So 15,000 times 0.75 to the 5th power. 0.75 to the 5th power is equal to 0.237. So 0.237, and then I multiply that by 15,000 times 15,000. 3,559.57. I'm going to cut it off here. If this was a 6, I would put an 8 here. I would round it to the nearest cent. There's only hundredths in cents. So it's going to be equals, oh, I forgot what it was. 3,55957. 3,55957. So my final answer is her motorcycle will find the value of will cost, I'll put cost. 3,559.57 after 5 years. Yes, you have to put a sentence. Hope this was helpful.